Okay, so again, this is chapter 19.4, graphs of quadratic functions. The concepts we're going to go over in these notes are looking at quadratic functions in different forms. So the first form that we're going to look at is when the function f of x is equal to x squared plus k. Then we're going to look at the form f of x is equal to x minus h squared. And then f of x is equal to ax squared. And then lastly, when f of x is equal to ax minus h squared plus k. So all of these forms are all quadratic functions. There's just different ways to write them. And they're different ways to write them based on the information that we're given. So in some cases, we're only given a certain amount of information that we're able to only write the quadratic form as concept 4, where we have a times x minus h squared plus k. Okay. So looking at concept 1, where we have f of x is equal to x squared plus k, we're going to define some vocab. So we have parabola. And a parabola is just another name for the graph of a quadratic function. So it's another name for a quadratic graph. We can have a parabola that goes up or a parabola that goes down. So facing in either direction. When they're facing in opposite directions, we get what is called the vertex. So the vertex is the highest or lowest point on a parabola. So it's the highest or lowest point on a parabola. So for example, if we had our parabola facing up, our vertex would be that lowest point at the bottom. If we have our parabola facing down, that means we have a vertex at the highest point at the top. So it's where these parabolas start to curve back around is where your vertex is. And then last vocab here, we have the axis of symmetry. Axis of symmetry. And that is the vertical line that passes through the vertex. So it's the vertical line that passes through the vertex. And what this axis of symmetry does is it divides the parabola equally in half. Okay? So for example, if we had our parabola pointing up, we know our vertex is that lowest point, and our axis of symmetry is going to be the line that goes through that vertex. Same with when our parabola is facing down. We have our vertex at the highest point and our axis of symmetry going through our vertex. Okay. all the axis of symmetry does, it tells us where it's divided in half equally. So, for example, so if we had, for example, so on your notes you have two graphs here. I'm just going to look at one of the graphs. So this is the first graph that's on the notes. Notice how it is a parabola that is facing up. So it's right about here. Our vertex is that point at the bottom. The axis of symmetry goes through that vertex, which is at x equals -2. So when we are writing our axis of symmetry, it's always going to be an equation. So it's going to be, in this case, always x equals whatever number is that first point in the vertex. So remember, our point is x comma y. So that first point will always be x. Again, this is looking at that first example. And then let's see, we have some more information in that red box. So it says a function of the type f of x equals x squared plus k represents a vertical shift of f of x equals x squared. So I'm going to write that. So f of x equals x squared plus k is a vertical shift of f of x equals x squared. Think of f of x equals x squared as our parent function. That's the original function. So if we are adding or subtracting a number from that, in this case, it is going to shift vertically. And vertically is what direction? Up and down. So that means that plus k is going to make it either move up, or if we had a minus k, it's going to make it move down. Okay. And that's all it says in the rest of that box. So if k is positive, it moves up. If k is negative, it moves down. So I'm going to write that here. If k is greater than 0, moves up. If k is less than 0, moves down. Okay, and that's the important information from that box. So looking at the first example, so example 1, we have three functions here. So we have f of x is equal to x squared. We have g of x is equal to x squared plus 1, and h of x is equal to h squared minus 2. Okay, so remember we said this is the parent function. Okay, meaning g of x and h of x are going to have a vertical shift. So looking at g of x, this plus 1 tells us we're going to have a vertical shift that goes which direction? Up or down? Up. So this is going to go up 1. H of x has x squared minus 2. That tells us we're going to have a vertical shift that goes which direction? down 2. And we can see that in the graph. So in order to graph this, I'm going to create a table for each one. And on the notes, I leave you space on the sides to create that table. So starting off creating a table, I am going to go ahead and have whatever values I want to plug in for x. I'm always going to stick with 1 positive, 1 negative, and a 0. So I'm going to do, let's see, yeah, I'll do -1, 0, 1. And then I'm going to be plugging in for my first equation, which is that f of x equals x squared. Then my next equation, g of x is equal to x squared plus 1. And then h of x is equal to x squared minus 2. Okay, so I'm going to be plugging in -1, then plugging in 0, then plugging in 1 for each of these equations. Okay. Did all you guys go in this row? Did you guys all go to advising? Okay, go ahead and go right out the doors, and there's the visor out there. Okay. So plugging in -1, we have -1 squared, which is 1. Plugging in 0, 0 squared, which is 0. And then 1 squared, which is 1. And we're doing that for every single one. So for the g of x1, we have -1 squared plus 1, so that's going to give us 2. 0 squared plus 1 gives us 1. And 1 squared plus 1 gives us 2. Okay. Notice from this function to this function, it was 1 up. We added 1. That's showing you that g of x function is shifting up 1. Now looking at our h of x function, we have -1 squared minus 2. So that's 1 minus 2, -1. 0 squared minus 2, which is -2. And 1 squared minus 2, which is -1. Again, comparing our parent function to our new function, notice how this went down 2. So 1 to -1, 0 to -2, 1 to -1. It went down went down 2 units. Okay, so we see that on the table. Now let's go ahead and graph that and see that on the graph. So we're going to plot all of these functions on one graph. So on the notes, I'm going to highlight them each a different color, just so I know when I'm graphing them which function is being graphed. And I'm just going to graph these points that I created. So for the first parent function, I have -1, 1. So that's what I'm going to plot first. So -1, 1. Then I have 0, 0. And then I have 1, 1. So -1, 1. I plotted that first one in the wrong direction. Okay, so that's my parent function. Okay, then I'm going to use the points to plot my g of x function. So -1, 2. So -1 and then 2. And then 0, 1. And then 1, 2. So again, notice how this just shifted my graph up 1. Okay. Now my last function, that h of x, I'm going to plot -1, -1. So -1, -1. 0, -2. And 1, -1. And again, see how when I graphed this one moved my function down 2. Okay, so remember we're looking at the parent function, which I have in pink, and then the other two functions, how one shifted up and the other shifted down. Okay. Any questions on number 1? Okay, now example 2. Example 2, it wants us to graph the function m of x is equal to x squared minus 4. What is that minus 4 telling us? Down 4. Okay. So what we need to do first is we need to make our table for this function, plot a couple points, and then we'll have our graph. Okay, so we have x, and then we have m of x is equal to x squared minus 4. Again, I'm just going to plug in 3 numbers. I'm going to plug in a positive number, 0, a negative number. So I'm just going to do the same one, so -1, 0, 1. Plugging in -1, I have -1 squared minus 4. So that's 1 minus 4, so -3. Then plugging in 0, I have 0 squared minus 4, so that's -4. And then lastly, I have 1 squared minus 4, which is -3. Notice how when I plug in my numbers, so for example, my x value of -1 and my x value of 1, I get the same y values. And that's because our parabolas are symmetric. Okay? So that means on either side of that 0, I should be getting the same points because I want my parabola to be symmetric down the axis of symmetry. Okay? So that's just something to note. So if I have my graph, I'm going to go ahead and plot these points. So I have -1, -3. So -1, -3. Then I have 0, -4. And then I have 1, -3. So if I was to graph this, this is what my equation would look like. And this is the easiest and fastest way to get a more accurate graph. Okay, we got to create that table. Obviously, the more points you plug in for x, the better your graph is going to look. Here, I just plugged in 3 points, so I'm not too sure if these points all up here are as accurate as my line is. Okay, but this is just asking us to graph, and as long as I see a couple points there on the graph, that's fine by me. Okay, so let's look at example 3. So example 3 wants us to do the same thing, but now we have the graph of n of x is equal to x squared plus 7 over 2. What is that plus 7 over 2 telling us? It's going to go up 7/2, which is approximately what as a decimal? 3.5. So this is going to go up 3.5 units. So we're going to create our table. And again, you can use any numbers you want for x. I'm just going to continue using -1, 0, 1. Okay, you could use -3, 0, 3. You could use any numbers you want as long as one is negative and one is positive, and then you have your 0. So plugging in -1, I get -1 squared plus 7/2. So that's 1 plus 7/2, which we said 7/2 is about 3.5, so this is 4.5. And then 0 squared plus 7/2 is 3.5. And 1 squared plus 7/2, remember, is going to match our other side of our parabola at -1, so it's 4.5. Okay. So then graphing this, we have -1 and then 4.5. That's right about here. And then we have 0, 3.5. Okay. And then we have 1, 4.5. So notice from our original parent function, because remember our parent function always starts at that origin, 0, 0, our entire graph moved up 3.5 units. Any questions on concept 1? So in concept 1, we just learned that if we have that plus k at the end, it's moving up or down. So for concept 2, we have the function f of x is equal to x minus h squared. So if the first function moved our graph up and down, what do you think this function is going to do? Left and right. Okay. So this function creates a horizontal shift. Remember, horizontal, left and right. So it says if our h value is positive, so if h is greater than 0, if it's positive, then our graph is going to move to the right. If our h value is negative, or h is less than 0, then our graph is going to move to the left. Okay. And that's all that box is saying on the notes. Okay, so looking at example 4, we have the graphs f of x is equal to x squared, and that is called our what? What type of function?
Quadratic. Parent.
Good, quadratic, but it is our parent function because nothing is changing on that quadratic. Okay, then we have the function g of x is equal to x plus 1 squared. And then we have h of x is equal to x minus 2 squared. So this plus 1 right here tells us that we are going to move to the left 1. So think of the signs as a little opposite, because remember in our formula, h is already assumed to be negative. So in order to make that positive 1, h would have to be negative, which means less than 0 to move left. So just think, if you see a positive number, it moves left. If you see a negative number, it moves right. So that plus 1 tells us it's going to move left 1. What about this minus 2? Right 2. So we are going to, let me see, good. Okay, so we're going to see that when we create our table. So we have x, then we're going to be showing what it looks like for our parent function, x squared. Then for our next function, that x plus 1 squared. And then lastly, for our h of x function, x minus 2 squared. And again, I'm just going to plug in the same numbers. I'm just going to plug in -1, 0, 1. Obviously, the more numbers you plug in, the better your graph is going to look. Okay. So I have -1 squared, which is 1. 0 squared, which is 0. 1 squared, which is 1. So that's my points for my first graph. Then I have -1 plus 1 squared, which is 0 squared, so 0. Okay. And then 0 plus 1 squared, which is 1. And then 1 plus 1 squared, which is 2 squared, which is 4. Okay, so those are my points for my g of x function. And then lastly, I'm plugging in for my h of x function, so -1 minus 2 squared gives me -3 squared, which is 9. And then 0 minus 2 squared gives me -2 squared, which is 4. And 1 minus 2 squared gives me -1 squared, which is 1. So from here, I'm going to go ahead and graph these points. Okay, and I'm just going to, again, highlight them so I know on my graph which one is which function. So I'm starting off with my parent function. In my parent function, I have the points -1, 1, 0, 0, and 1, 1. So that's my parent function, and my parent function always looks the same. So it's always that x squared. Now on my g of x function, when I plot this, I should see that my graph goes to the left 1. So plotting those points, I have -1, 0. I have 0, 1. And then I have 1, 4. So somewhere over here. Notice how it only plotted one side of that parabola, but I know that my parabolas are symmetric, so I'm just going to follow it the other direction. Okay. So that shows us from the parent function, it moved left 1. Now, lastly, plotting h of x, we have -1, so -1, 9, I'm just going to say is way up here. 0, 4, and then 1, 1. So again, I know that my parabola is symmetric, so I know it's going to have that other side of the curve going the other direction. So here it shows me that I am going to the right 2 compared to my parent function. Okay, go ahead and take a moment and do number 5. So example 5 is p of x is equal to x minus 7 squared. So go ahead and create your table and then graph it. I think that was everybody. Did everyone go out?
I think I talked to everybody, right? Okay. All right, I appreciate it. Good luck to you guys. Thank you.
Okay, thank you. So you're working on number 5. Number 5 is telling you we're going what direction? 7. Right. So you're going to go ahead and create your table and then plot your graph. So everyone should be setting up their table. I'm going to go ahead and set up mine. Remember, you can use any numbers you like. I'm just going to continue using my same numbers. So plugging in some numbers, again, I just plugged in -1, 0, 1. When I plugged in those numbers, I noticed I only got half of my parabola, but since I know it's symmetric, I know it's going to create that U. And your graph should look something along the lines as this. Okay. Remember, I only plotted a couple points. The more points you plot, the better your graph looks. The important part here is that we're seeing from the parent function to the new function p of x, it moves to the right 7 units. Any questions on number 5? And again, I'm creating like a rough sketch of my graph, so since my numbers were so large, I'm just assuming that top point was at 64, the middle point's at 49, and then down to 36. And then last example for this concept is example number 6. And we have the function q of x is equal to x plus 1.6 squared. That plus 1.6 tells us our graph is going to do what? To the left. Because remember, if we see minus that number, it's to the right, plus that number, it's to the left. So this is going to go left 1.6 units. Okay. So again, I'm creating my table with any points I want. And I'm going to be plugging them into that q of x function. So I have -1 plus 1.6 squared. -1 plus 1.6 is 0.6. 0.6 squared gives me 0.36. Then plugging in 0, 0 plus 1.6 squared is going to give me 1.6 squared. Which is 2.56. And then 1 plus 1.6 squared gives me 2.6 squared, which is 6.76. If you ever have decimals that go past the 2 places, just round it always to 2 places. So graphing this, I have -1 and then positive 0.36, so it's very small. Then I have 0, 2.56, so I'm going to say that's here. And then I have 1 at 6.76, so about here. Okay? It looks like it's going to be a line, but since we know it's quadratic, it's symmetric, so I'm going to start forming my curve around. And I know my graph is going to look somewhat like this. And this is telling me from the parent function that we moved 1.6 units to the left for this q of x function. Okay. Any questions on concept 2? So we talked about up and down, moving the equation left to right. Now we're going to look at concept 3. And concept 3 is when we have the function f of x is equal to a times x squared. Okay. So what do you think the a value in front of x squared is going to do to our function?
Making it either more wide or narrow.
Good. So that's one thing. It could either make it wider or more narrow. And there's one more thing that a value does. Correct. It could turn it upside down. So if our a is negative, it could go facing downward. If it's positive, it would face upward. So looking at these properties, so if a is positive, then the parabola opens up. So like this. Opens up. Okay. If the parabola is negative, so a is less than 0, it's going to open down. Okay. If a is a fraction, so like we had 1/2 x squared, that means the parabola is going to get wider. Okay. And then lastly, if a is a whole number, the parabola will be narrow. Okay, so this is what a does to our parent function. Okay. So looking at example 7, we have our parent function, f of x is equal to x squared. Then we have g of x is equal to 2x squared, and h of x is equal to 1/2 x squared. So looking at g of x, that 2 tells us what two things? a value of 2 in front of x squared, looking back up at our definitions up here, does what two things to the graph? Good, it's going to be narrow and opens up. So narrow, opens up. What about that 1/2? Good, it's going to be wide and opens what direction? Up. Remember, if it's positive, it opens up. If it's negative, it opens down. So that means all of our functions here are going to be opening up. Okay. So in order to graph these, we're going to create our table. So for a lot of these problems, you're just plugging in numbers and then plotting points. And then to show you that you could use any numbers here, I'm going to go ahead and use -3, 0, +3. Okay. So if I'm looking at my parent function, I have -3 squared, which is 9, 0 squared, which is 0, and 3 squared, which is 9. Again, I'm showing you that you can use any numbers as long as you have a negative, a 0, and a positive number. Then for g of x, I have 2 times -3 squared. So -3 squared is 9. 9 times 2, 18. Notice all my answers that I got in my parent function, for my g of x function, I'm just going to be multiplying by 2. So 2 times 0 squared is 0, and 2 times 3 squared is 18. And then for h of x, it's just going to be half the value of my parent function. So I have 1/2 times -3 squared, which is 4.5. 1/2 times 0 squared, which is 0. And 1/2 times 3 squared, which is 4.5. Okay. Notice that all of my origins are the same. So that means they share the same vertex. It's all going to be at 0, 0. The only thing that's changing is the numbers on either side. So either they're smaller or larger, depending if they're going to be narrow or wide. Okay, so now plotting these points, I'm going to plot -3, 9. Oh, wait. Can't say that's 9. Say this is 9. Okay. 0, 0. And then 3, +3, 9. So that's my first one. And again, this is a sketch, so I'm assuming where I plotted that point is 9. And then I have -3, 18. So we're going to say this one is this. 0, 0, and then 3, 18. Okay. And then I have -3, 4.5. So I'm going to say that is right here. Oh, wait. -3, 4.5. Okay, which is out here. So if the graph I have in pink is my parent function, looking at the graph in green, notice how it went narrow, skinnier, and then the graph that I have on blue is wider. Okay, so that correlates to what we said is going to happen in before we even started our table. Okay, because we said g of x is going to be narrow and h of x is going to be wide. Okay, any questions on 7? Okay. Example 8. We have our parent function, f of x is equal to x squared. We have our g of x, which is equal to negative 3x squared. And our h of x, which is equal to negative 1/3 x squared. So looking at our a value in g of x, that negative 3 tells us what two things? Good, it's going to be narrow, opens, down. Is our parent function going to open down? No, our parent function is still opening up. What about that negative 1/3 in our h of x function? So it's a fraction, so it's going to be wide, and it's negative, so it's going to open down. Okay. So again, I'm going to go ahead and create my table. And I'm going to use that negative 303 again. So I have x, f of x is equal to x squared, our parent function. G of x is equal to negative 3x squared. And then h of x is equal to negative 1/3 x squared. And again, I'm going to be plugging in negative 303, but you could choose any numbers you want. So negative 303. So I have negative 3 squared, which is 9, 0 squared, which is 0, and 3 squared, which is 9. I'm just plugging in those x values. Okay. Notice that my g of x function is going to be my numbers that I got from my parent function, but multiplied by a negative 3. So I'm going to have negative 3 times negative 3 squared, and that is going to give me negative 27. Negative 3 times 0 squared is 0, and negative 3 times 3 squared is negative 27. And then the opposite's going to happen for my h of x. My parent function values are going to be divided by a negative 3. So negative 1/3 times negative 3 squared is equal to negative 3. Negative 1/3 times 0 squared is 0. And negative 1/3 times 3 squared is positive 3. Again, they all share that same origin, that same vertex at 0, 0. The only thing that's happening is that some of the numbers are getting smaller, some are getting larger. So it's going to create that effect of our graph getting skinnier versus wider. Okay, so plotting my parent function first, I have negative 3, 9. 0, 0, and positive 3, 9. Okay, notice my parent function is still going up because my parent function does not change. Okay. Then I'm going to plot my next point. So negative 3, negative 27, 0, 0, and then positive 3, negative 27. This one is now pointing down because of that negative. And then lastly, plotting -3, -3, 0, 0, and then 3. That was supposed to be a negative. -3. Again, this is facing down because our a value is negative, and it's also wider than that g of x function because it is a fraction. Okay, any questions on concept 3? We have one more concept, and that's concept 4. Okay. Concept 4 is putting every concept that we just learned, so whether it's going up and down, left or right, facing up, facing down, wide, narrow, all of those are now combined into our concept 4, which is the function f of x is equal to a x minus h squared plus k. Okay. This form is called vertex form. This is called vertex form. The reason it's called vertex form is because from this equation, we can find the vertex without doing any math. Because the vertex, in this case, is always going to be h, k. H, k. Notice we have h and k in our formula. Another important factor about this equation is that we can find the axis of symmetry from this equation because we know it's going to be x equals h. X equals h, that first point in the vertex. And then next, if a is positive, so that means it opens up, that means k, this implies that k is the minimum value. And then the opposite is true. If a is negative, then k is the maximum value. Okay. So this is telling us that yes, this equation gives us the vertex, and from the vertex we're able to determine if it is a maximum or a minimum. So if the vertex is on the bottom, it's a minimum. If the vertex is on the top, it's a maximum. Okay. So let's go ahead and look at example 9. Example 9 gives us the function f of x is equal to 2 times x minus 3 squared cubed. On the notes it says cubed. It should be squared because we're talking about quadratics. Plus 4. Okay. And then from here, before we answer any of the questions, we're going to determine what this is going to do to our problem. So remember that our h value is the opposite sign. So even though that this says -3, our h value is actually +3. It's always the opposite sign. So this one tells us that our h is going to be 3, and our k is going to be that last number, which is 4. This is every single time. Your h value is always in the parentheses, and it's the opposite sign. and your k value is always at the end. Okay, so knowing that, let's go ahead and answer some of the questions. It says find the vertex. So remember, the vertex is what point? What comma what? We said it in the little notes. Good. Vertex is always h comma k, and we just identified our h and our k, so that means our vertex is at what point? 3 comma 4. So perfect, that's our vertex. Okay. Then it says graph the function. Okay. Remember, when we graph, we're just going to have a couple points in there. So I'm going to create my table with my f of x function. And I'm just going to plug in 3 numbers, so -1, 0, 1, and see what I get. So I have 2 times -1 minus 3 squared plus 4. -1 minus 3 is -4. Okay. -4 squared is 16. 16 times 2 is 32. 32 plus 4, 36. Or you could just type that all into your calculator. Then plugging in 0, I have 2 times 0 minus 3 squared plus 4. 0 minus 3 gives me -3. -3 squared is 9. 9 times 2 is 18. 18 plus 4, 22. Or again, plug it into your calculator. And then next, I am plugging in 1. So I got 1 minus 3, which is -2. -2 squared, which is 4. 4 times 2 is 8. 8 plus 4 is 12. Okay. So technically, I have 4 points I can plot here. I can plot my 3 that I just found, and I can plot my vertex. Okay, so I'm going to plot my vertex first. So positive 3, 4. That's my vertex. And then I have -1. Oops, I plotted it on the wrong side. Right here. Then I have -136. So -136, I'm just going to say is way up here. And then I have 0, 22. I'm going to say that's here. And then I have 1, 12, so right here. So I have half of my parabola. I know my parabola is symmetric, so I'm going to draw the other side here. And my graph looks something like this. The next part, it wants us to find the axis of symmetry. What was the formula I gave in above to find the axis of symmetry? It's x equals h. X equals h. And what was h? 3. So x equals 3. That is my axis of symmetry. So right here at 3, my axis of symmetry is what divides my parabola in half. Then it wants us to identify if this is a maximum or a minimum. So looking at the vertex on the parabola, is that vertex on the bottom or is it on the top of our parabola? So we're looking right here at the vertex. Is that on the bottom or the top? So it's on the bottom. So remember, we can have our parabola 2 ways. We can have it pointing up and it's on the bottom, or pointing down and it's on the top. So since this is on the bottom, this is a minimum. So this is a minimum. And remember, our minimum is always going to be k equals What is our number that we got for k? 4. So our minimum is at k equals 4. Next, it wants us to find the domain. And who remembers what the domain of a quadratic function is? Always. Never changes. All real numbers. Anytime you see a quadratic, the domain is always all real numbers, or that fancy R. So all real numbers. Okay. And then lastly, when we find our range is always going to have that minimum value in it. So in this case, what was our minimum value? 4. And is our graph pointing up or down? Up. So is it going towards infinity or negative infinity? Positive infinity. So that means we're going to have 4 with a bracket, because that 4 is included, all the way up to positive infinity. So our range is always going to include the k value. Always going to include the k value. So again, we use everything that we just learned, and we created a problem that this is the type of problem that you would see on a test, like example 9, where you're using every single concept we just learned, and they would give you a function like example 9, and they could ask you questions like this, or they could ask you questions like, okay, in which direction is it shifting left? How many units is it shifting left? How many units is it going up? And you would have to look at this equation and know what each value is changing the function. So last example here, we have example 10. We're doing the same exact thing, going through all those questions. So example 10, we have the function g of x is equal to negative x plus 2 squared minus 7 over 4. Okay. So before we answer the questions, let's go ahead and see what this graph is going to do. Okay. So looking at our a value is a negative 1 right here. This is our a value. That a value of negative 1 is going to tell us what two things about our function? Opens down, and since it's a negative 1, that 1 is telling us what? Is it going to be wide or narrow? So it's a whole number, so is it wide or narrow? Good, it would be narrow. Okay. What is that plus 2 right here telling us? It's going to shift in what direction? Good, left 2. And what is this negative 7/4 tells us? Good, down 7/4. And 7/4 is approximately what as a decimal? Let's see if I wrote that. 1.75. I'm just going to use that decimal because it's easier to graph than the 7/4. Okay, so we identified everything that this function does. Now we need to identify what our vertex is. And remember, our vertex is what? H, comma, K. In this case, what is our H? So remember, it's always opposite sign. Good, negative 2, so this is negative 2, and then what is our K value? Good, negative 1.75. or negative 7/4, whichever you prefer to write. But this is easier to plot. Okay. So from here, now we're graphing. And then remember, in order to graph, we need a couple more points. So we have 1 point of the vertex. Now let's get, let's say, our 3 more points. And I'm just going to write minus 1.75 at the end because we know that's 7/4 to make it easier when we're plugging into our calculator. So I'm going to go ahead and try negative 303. So then I have negative parentheses negative 3 plus 2 squared minus 1.75. Okay, negative 3 plus 2 is negative 1. Negative 1 squared is positive 1. But we have another negative there, so this is negative 2.75. Then I'm going to plug in 0. When I plug in 0, I get 2 squared, that's 4, negative 4, so this is negative 5.75. And again, you can find this just by plugging the whole thing in your calculator using those parentheses. And then lastly, I'm plugging in a positive 3. And I get 3 plus 2 is 5. 5 squared is 25. Negative 25, so this is negative 26.75. So now I have 4 points that I can plot, the 3 points that I found, and my vertex. So plotting my vertex, I have negative 2, negative 1.75, so about right here. And then I have negative 3, negative 2.75, about right here. I have 0, negative 5.75. And then I have 3, negative 26.75, so down here somewhere. Okay. Remember, my vertex is what tells me where my turning point is. So that means my graph is going to look something like this. Okay. And then from my graph, I'm able to find my axis of symmetry. And my axis of symmetry is always going to be x equals what? Not k, h. Always x equals h. And what is h? Negative 2. It's always that first number in our vertex. So if I look at h, or k, x equals negative 2, that's right here. Okay? Remember, this tells us where our parabola is divided evenly in half. Okay? Now looking at this, does it have a maximum or a minimum? Where's the vertex? Is it at the top of our graph or the bottom of our graph? The top. So since the vertex is right here at the top, this is a maximum. Okay, so this is a maximum at k equals what? What was our k value? Negative 1.75. Good. Then we said the domain is always what? All real numbers. So that fancy R, or you could write all real numbers, or you could write negative infinity to positive infinity. Those are all the same answers. And then lastly, for our range, I said our range is always going to include what value? H or K? It's going to include K. So since our graph has a maximum, that means our graph is pointing down. So it's going to go towards which infinity? Negative infinity. So we have negative infinity to negative 1.75 because that's our k value. And are we going to include it with a bracket or not include it with a parenthesis? Bracket or parenthesis? Bracket, because this is our vertex, right, up here, and that is a point on our graph, so it is included. So we're always going to have a bracket when we're dealing with the range of our quadratic functions.